Hi everyone, this is YVR. Welcome to YVR Maths Tutorial. In the previous videos, we have discussed the concepts of direction cosines and direction ratios from the chapter 3-dimensional geometry. We have already discussed few of the applications on these concepts from Ncert exercise 11.1. Now, I am going to discuss some more applications based on this concept direction cosines and direction ratios from Ncert exercise 11.1. If you did not watch previous videos, I will give you the links in the description card. To understand the concept easily, watch this video till the end. Let's begin today's class. In previous classes, we covered two models. Now, we will start the class with the third model. Question number 5. If a line has the direction ratios minus 18, 12, minus 4, then what are its direction cosines? If we know the direction ratios, how to find the direction cosines? We have learned this concept in the previous classes. I will give you that statement here. If A, B, C are direction ratios of the line, then the direction cosines of the line are plus or minus over root a square plus b square plus c square, comma, plus or minus b by over root a square plus b square plus c square, comma, plus or minus c by over root a square plus b square plus c square. According to the given question, the direction ratios of the line are minus 18, minus 12, minus 4. We can consider these numbers as a, b, c because the direction ratios generally we can denote with a, b, c. Now we can find over root a square plus b square plus c square value. Now root of a square plus b square plus c square is equal to over root minus 18 whole square plus 12 square plus minus 4 whole square. That is equal to over root minus 18 whole square is 324 plus 12 square is 144 plus minus 4 whole square is plus 16. That is equal to the sum of these numbers is 484 over root. What is the root value of 484? 22. Therefore, the direction ratios of the required line are, substitute the values in the formula, plus or minus minus 18 by 22, comma, plus or minus 12 by 22, comma, plus or minus minus 4 by 22. If we cancel the numerator and denominator numbers with the second table, then the new direction cosines are minus or plus 9 by 11, comma, plus or minus 6 by 11, comma, minus or plus 2 by 11. So, these are the direction cosines of the given line. I will give you the similar model for your self-practice. Question number 6. If the direction ratios of a line are 1, 1, 2, then find the direction cosines of the line. So you can proceed the same process what we discussed in the 5th question. Let me take 7th question. Find the direction cosines of the line passing through the points P 2, 3, 5 and Q minus 1, 2, 4. If we know the endpoints of the line segment, how we can find the direction ratios of that line segment? That concept we learned in the 2nd class. I will remind you that statement. We know that the direction ratios of the line segment joining the points A, x1, y1, z1 and B, x2, y2, z2 are x2 minus x1, y2 minus y1, z2 minus z1. According to the given question, the given points are P, 2, 3, 5 and Q, minus 1, 2, 4. You can consider P, 2, 3, 5 is the point A, x1, y1, z1 and Q minus 1, 2, 4 is the point x2, y2, z2. Now, you can substitute these values in the formula, then the direction ratios of the line joining the points P and Q are minus 1 minus 2, 2 minus 3, 4 minus 5. That is minus 3, minus 1, minus 1. So these are the direction ratios of the line segment joined by the points P and Q. I will give you the similar model for your self-practice. Question number 8. Find the direction ratios of the line joining the points A, 1, 2, minus 3 and B, minus 1, minus 2, 1 directed from A to B In the previous question, what is the process or what is the formula we applied? You can follow the same process and the same formula to get the answer for this question. Next model, question number 9. Show that the points 2, 3, 4, comma, -1, -2, 1 and 5, 8, 7 are collinear. In the given question, they given 3 points. Show that the given 3 points are collinear. So how we can prove the given 3 points are collinear? First of all, let us consider the given 3 points are A, B, C. So let the given points are A, 2, 3, 4, comma, B, -1, -2, 1 and C, 5, 8, 7. What is the meaning of collinear? If 3 or more points lies on the same line, then we can say the points are collinear. In this question, they given 3 points. Let us take the 3 points lies on the same line A, B, C. If you observe this diagram, AB is one line segment and BC is another line segment. Now I am going to find the direction ratios of the line segment AB and the direction ratios of the line segment BC. If these two direction ratios are proportional, then we can say the given points are collinear. So first of all, I am going to find the direction ratios of the line segment joining the points A and B. Therefore, the DRs of the line joining A and B are. What is the formula to find the direction ratios? If you know the endpoints of the line segment x2 minus x1, comma y2 minus y1, comma z2 minus z1. A point is x1 y1 z1 and B point is x2 y2 z2. So substitute the corresponding values. -1 -2 comma -2 -3 comma 1 -4. That implies -3 comma -5 comma -3. Let us consider this set of direction ratios A1, B1, C1. Now I am going to find the direction ratios of the line segment B and C. Again, the DRs of the line joining B and C are again same formula x2 minus x1, y2 minus y1, z2 minus z1. Here B point is x1 y1 z1 and C point is x2 y2 z2. If we substitute the values in the formula 5 minus of -1, comma 8 minus of -2, comma 7 minus 1. That implies 6 comma 10 comma 6. Let us consider this set of direction ratios A2, B2, C2. Now we got two set of direction ratios. One is AB line segment direction ratios, another one is BC line segment direction ratios. Now we have to check these two set of direction ratios are proportional or not. See here, -3 by 6 is equal to -5 by 10 is equal to -3 by 6. These are proportional with the proportional constant -1 by 2. That means it satisfies the condition A1 by A2 is equal to B1 by B2 is equal to C1 by C2. So by using this explanation, what we can say? The direction ratios of the line segment AB and BC are proportional. Therefore, AB is parallel to BC, but point B is common to both AB and BC. Hence, points A, B, C are collinear. I will give you similar model for self-practice. Question number 10. Show that the points 1, 2, 3, comma, -2, 3, 4 and 7, 0, 1 are collinear. So you can follow the previous question process to complete this question. Now, next model, question number 11. Find the direction cosines of the sides of the triangle whose vertices are 3, 5, -4, comma, -1, 1, 2 and -5, -5, -2. So, what is this question? They given the vertices of a triangle. Then find the direction cosines of the sides of a triangle. So how many sides we will get for one triangle? Obviously 3 sides. So now we have to find 3 set of direction cosines by using the given vertices of a triangle. First of all, let us consider the given vertices are A, B, C. Let the given vertices of the triangle be A, B and C respectively. That is A 3, 5, -4, B -1, 1, 2 and C minus 5, minus 5, minus 2. Now I will mark these three vertices in the diagram. So this is the triangle, vertex A, vertex B and vertex C. If we observe this diagram, we have three sides AB, BC and CA. So first of all, I will find the direction cosines of the side AB. So before going to find direction cosines, first of all, I will find the direction ratios. If you know the direction ratios of the line segment, you know how to find the direction cosines. Now I will find direction ratios of line AB. Direction ratios of line AB are, let us take the formula, x2 minus x1, y2 minus y1, z2 minus z1. Here we are finding the direction ratios of AB side. So A is x1, y1, z1 and B is x2, y2, z2. If you substitute the values in this formula, minus 1, minus 3, 1 minus 5, 2 minus of minus 4. That is minus 4, minus 4 and 6. Let us consider these three numbers as A, B, C. So we got the direction ratios of the side AB. Now how to find the direction cosines if you know the direction ratios? We need the value of over root A square plus B square plus C square value. So let us find root of A square plus B square plus C square value is equal to root of minus 4 whole square plus minus 4 whole square plus 6 square. That is equal to over root 16 plus 16 plus 36. That is equal to over root 68. That is equal to 68 can be written as 4 into 7. That is equal to root 4 value is 2. That means 2 root to 17. Let us imagine the value 2 root to 17 is R. Now I am going to find the direction cosines of that side AB. Therefore the direction cosines of line AB are, we know the formula x2 minus x1 by R, y2 minus y1 by R, z2 minus z1 by R. Or one more formula, A by over root A square plus B square plus C square, B by over root A square plus B square plus C square, C by over root A square plus B square plus C square. You know A, B, C value and over root A square plus B square plus C square value. Just you can substitute all these values in this formula. Then minus 4 by 2 root 17, minus 4 by 2 root 17, 6 by 2 root 17. If we cancel the numerator and denominator terms by using the second table, then minus 2 by root 17, minus 2 by root 17, 3 by root 17. Now this is set of direction cosines I will write in another way. See here, 2 by root 17, 2 by root 17, minus 3 by root 17. So how I wrote this set of direction cosines like this? We have discussed already this concept in the previous classes. I will give the point here. If L, M, N are direction cosines of a line L in one direction, then minus L, minus M, minus N are also direction cosines of the same line. So based on this concept only, I wrote this set of direction cosines like this. We got the direction cosines of the side AB. Now let us find the direction cosines of another side BC. So before finding the direction cosines of the side BC, I will find the direction ratios of that side BC. So direction ratios of the line BC are the same formula, x2 minus x1, y2 minus y1, z2 minus z1. Here B point is x1, y1, z1 and C point is x2, y2, z2. If we substitute the corresponding values here, then minus 5 minus of minus 1, minus 5 minus 1, minus 2 minus 2. That is minus 4 minus 6 minus 4. Let us consider these numbers are direction ratios of the side BC. That is equal to A, B, C. Now we got the direction ratios of the side BC. To find the direction cosines, we need under root of A square plus B square plus C square value. Let us find root of A square plus B square plus C square value. That is equal to over root minus 4 whole square plus minus 6 whole square plus minus 4 whole square. That is equal to over root 16 plus 36 plus 16. That is equal to over root sum of all these numbers is 68. Now 68 can be written as 4 into 17. The root of 4 is 2. That's why we are getting 2 root 17. Let us imagine this is R. Now to find the direction cosines of the side BC, we have a formula. Therefore, the direction cosines of line BC are x2 minus x1 by r, y2 minus y1 by r, z2 minus z1 by r, or a by over root a square plus b square plus c square, comma b by over root a square plus b square plus c square, comma c by over root a square plus b square plus c square. You know what is ABC? You know what is the value of r. Just you can substitute here. Now minus 4 by 2 root 17, comma minus 6 by 2 root 17, comma minus 4 by 2 root 17. If we cancel the numbers from the numerator and denominator by using the second table, we will get minus 2 by root 17, comma, minus 3 by root 17, comma, minus 2 by root 17. So, we got direction cosines of the side BC also. Now, let us find the direction cosines of the side CA. Before finding the direction cosines of the side CA, first of all, we will find the direction ratios. The direction ratios of line CA are the same formula x2 minus x1, y2 minus y1, z2 minus z1. Substitute the corresponding values 3 minus of minus 5, comma 5 minus of minus 5, comma minus 4 minus of minus 2. That is 8 comma 10 comma minus 2. So these are the direction ratios of the side CA. Let us imagine these numbers A, B, C. To find the direction cosines, we need over root a square plus b square plus c square value. Now we can find that value. Root of a square plus b square plus c square is equal to a value 8 square plus b value 10 square plus c value minus 2 whole square. That is equal to root of 64 plus 100 plus 4. That is equal to the sum of these numbers is 168. Now 168 can be written as 4 into 42. That is equal to 2 root 42. Let us imagine this number as R. Now, to find the direction cosines, we know the formula already. Therefore, the direction cosines of the line CA are, we are going to use the same formulas what we used in the previous part. That is 8 by 2 root 42, comma 10 by 2 root 42, comma minus 2 by 2 root 42. If we cancel the numerator and denominator terms by using the second table, the direction cosines of the side CA are 4 by root 42, comma 5 by root 42, comma minus 1 by root 42. So these are the direction cosines of the side CA. Finally, we got 3 set of direction cosines. First one is for the side AB, and second one is for the side BC, and the third one is for the side CA. Now I will give you similar model question for self-practice. Question number 12. Find the direction cosines of the sides of the triangle whose vertices are 1, 2, 7, 2, 6, 3, 3, 10, minus 1. Solve this question by using the same process what we discussed in the previous question. Thank you for watching this video. If you like, subscribe my channel and share to your friends. If you have any doubts regarding this class, feel free to contact through mail. My mail ID yvrhoneychowdary@gmail.com. In the next class, we will discuss the angle between two lines. Keep watching.